Alright, welcome back to another video on OpenFAST wind turbine simulation. Next we're going to be discussing how to take that OpenFAST file that you created and do fatigue testing on it. So we need to download a program called MLife. This is another set of scripts that MATLAB uses to determine fatigue, damage equivalent loads, rows loading, as well as lifetime and time to failure. There we go. That's what I was trying to remember. Time to failure. Okay, so what you're going to want to do is go into a browser and just type in MLife NREL. And it should be this first one. I was already on the web page before. You're going to go to downloads. You're going to want to download the EXE, the user's guide, and the theory manual. And when you download the EXE, it's highly recommended to have its own folder. Mine I keep in my school's folder because I'm using this for a school project, and it's called MLife testing, but it's recommended to do one straight on the C drive or wherever. Just remember where it's at. Now when you download this .exe, you're going to double click it and hit OK on the window that pops up, and then hit unzip, and it's going to create these folders and a couple of these files. So go into your source folder, double check that data table package and rainflow directories are there. Those are really important. Now you'll notice mine have this .out and .outb and a few other things that yours doesn't have. That's okay. We will need those, but I'll show you how to get those. Okay, first thing that we need to set up is the settings file. MATLAB uses this, or MLife uses this to do all the calculations. So to find a good settings file, go to cert test, grab this test01.mlife, copy it, and paste it into the source. Now go ahead and rename it to whatever you want. I renamed mine to settings file with a capital F right here, and I also have a copy of it just in case something messes up. I edit the copy. I keep the original settings file the same and the test01 the same, just so I have backups. Okay. Now, what is this .out and .outb? That's an excellent question. We do need those for MLife to work. This is what OpenFAST generates, is this binary file. But MLife prefers to use a ASCII or a text file. So we need OpenFAST to save the format into a .out rather than .outb. So how do we do that? That's an excellent question. Let's go to OpenFAST real quick. This is the one we've been using, the 5 megawatt land DLL wind turbine. If you go into the notepad and edit the .fst, you'll see that line 50 is the output, and it tells you that 1 is a text file, .out, 2 is a binary, which is usually what it produces, or 3 is both 1 and 2. So I just do 3. And that way I have both in case I need it. Okay, now that is all set up. Let's go ahead and open up the .out, and this is what it looks like. Line 7 has all our index names. So this is all the time series data. In this case, I don't know how many timestamps. I went way too far. I actually like close to 60,000, 55,000 time steps. So that's a lot of data. Anyway, whoops. Okay, so that's what this looks like. Okay, so moving on. Now we need to set up MATLAB to work correctly. The fastest way to do this is if you double click one of these files. I don't know, I'm going to double click compute fatigue. It'll open it up in MATLAB. It'll automatically put you in the working directory of the source folder and put your current folder as the source. Now on your left hand side, you'll probably notice that yours are very light colored and grayed out. That's because the path has not been set for those, and we need to do that. But we don't need this compute fatigue, so let's go ahead and close that. Now, if we click on Home, and then Set Path, we can hit Add Folder, and you're going to go ahead and add the Data Table Package and the Rain Flow folders, and you're going to hit Save, and you're going to hit Close, and OK, and then restart MATLAB. And by double-clicking one of these files. Now, the reason why I do this is because if you open MATLAB by itself, then you have to change where your current working directory is, and that's fine. But I just prefer to double-click one that's already in there, and then it opens up MATLAB right there. Okay, so now before we can even run MLife, we have to install an add-on. So you're going to click Add-ons, and it's going to take a minute to load. And you're going to search for statistics and machine learning. Click it. From here, you just hit install. Okay, mine's already installed, obviously. Click install, and then it's going to ask you to restart MATLAB. Go ahead and do that, and it should restart it to where you last left off. Okay, now we are almost there. What you need to do now is find your settings file, whatever you named it, and double click it, and it will open it right here. And that's the beauty of these files, that MATLAB can open them. So these are all kind of the options and things that it goes through. You can kind of read it, but let's start from the beginning. If you look right here, it says names line, line 7. This is the row with the channel names. That was what I was showing you a minute ago, how line 7 had all the index names. Okay, so leave everything blank except right here on yours. This will be different numbers. It'll be like 50, 51, 52, nope, 53 and 54, I think. In fact, let's just look at the test. Yeah, 50, 51, 53, 54. Those are the columns in their particular data, whoever made this file, that has the root fxb1, root fyb1, and the moments in the x and y direction. This is the columns that have that. Now, what do I mean by that? Well, remember in PyDatView in the last video how it shows all these things right here? They're saying that name 50 or column 50 is their root fxb1, when for us, or for at least for me, my root fxb1 is right here in the 29th position. Now, how do I find that? Well, I can count from starting at time as 1, 2, 3, 4, 5, all the way down, or in MATLAB, I think in the sources folder, it should have that same file we used in OpenFAST called readfast binary. If it does not, go find it, copy and paste it in here, and go ahead and run it. And then using the commands that I showed in the first one, such as this one right here, and remember how it creates these right here, you can go ahead and double click channel name, and look, for channel 29 is my root fxb1, fyb1, and then my moments is 33 and 34. These, actually not that, I want 32 and 33. So 29 and 30, 32 and 33 for me. So I'm going back to my actual settings file. Yeah, so 29 and 30, 32 and 33. Now you'll notice this equation is has a square root and the sum of squares. This is actually a statistical thing called root sum square. I think root sum squares. Let's double check that. Yeah, root sum squared. That's yeah, it's this business right here. RMS, root mean squared. I wonder if it has something to do with the same thing as. No, it's different than RMS. This is RSS. Okay. Anyways, you can read up on this. But that is not the equation that calculates fatigue. That is just, in general, for some statistical analysis. Okay, so now we've changed it to the correct numbers. Go down, don't mess with anything on the load rosing or roses. What that does is simulate different types of loading conditions that is more realistic, and we're not going to deal with that right now. So next we need to go to fatigue. Design life. We want, well, for my case, I want 20 years. I want my blade to last 20 years. Some people want theirs to last 30 years. So for 20 years, our goal is we need to find the maximum load that this blade can handle and survive for at least 20 years. And that's what MLife is good at doing. So I'm going to set it for 20 years. I'm going to set anything for XLS to true. What that means is it's going to write to an Excel file rather than a text file, because the text files are just difficult to read. And then equivalent frequency, 2.1. Now, how the heck am I getting this? I'm going to assume, I haven't tested this, but my theory is that every wind turbine test you're going to make using OpenFAST will be 2.1 as well. And how you find that is you open up PyDat view. You can do it in MATLAB, but it takes some time. We're going to do a fast Fourier transform. If you look at root force x on blade 1, okay, we want to find the frequency that we are needing. So we're going to hit FFT. Now some people, you can find the frequency. I accidentally found the frequency of the timestamps, and I was like, oh my gosh, I got a good frequency, and numbers were just really weird. And that's because I was finding the frequency of the data, not necessarily, like, it's how frequent it was taking the data. So hit FFT, and then you go to the first harmonic. Right here you'll notice here's X and Y, and it's roughly 2.10967. So 2.10. And that is the equivalent frequency that I'm using right here. Default is 1. Yeah, the frequency of the damage equivalent load. I think what this means is imagine the blade as a cantilever beam. So it's stuck into a wall. And you can come up to it, and pull down the blade and let it go, and it just oscillates for a few seconds up and down. I think it's saying that it takes 2.1 hertz, so it does 2 cycles per second. So in 1/1000 it has oscillated twice. That is what I think this is doing. Don't quote me on that. I'm still new to this. Okay, so next down here, channels. Put 29, 30, 32, 33. Slopes is 1. The Wohler exponent, or M, is going to be 10. And what I mean by that, if we go to MLife theory manual, let's take a peek at this real quick. So these are the equations that it uses. I would suggest reading up on this because it also shows all the nomenclature right here. La-di-da-di-da, everything you need to know. Okay, so focusing on damage equivalent loads, shows how it's done and whatnot. So M, we're using 10 right here. Usually it's either 3, 8, or 10. I'm choosing 10. I should do tests with 3 and 8 and see what happens. I don't know. I'll think about that. Anyway, so I suggest reading the manual. That's the theory manual. That's the theory manual. Okay. So now I set, so these values, so channels here, slopes here, slope list there. Bin flag is this BW. Max bin width number is this 10. Type LMF is the AM. That means aggregate mean. There's another one, I think, called WD, which is the Weibull distribution. It's just how it finds the load mean fixed, or the fixed mean load. The most accurate is the aggregate mean, so AM for this. And then the ultimate load. So how did I find these numbers? That's an excellent question. I'll talk about that here in a second. first, just leave it as the defaults. I think it's like 1750 or something. Just leave it as the defaults. Make sure you change this channel number from the from how they have 134, 52, 135, and 55, because our index only has 52, not 134. Most common errors, people forget to change these, and then it freaks out and says, hey, you only have 54 indexes or 52 indexes, but it's trying to pull 134 out of there. So be sure to change that. And here's the default value, 1750 right here. They're using different numbers for their LMF. Aggregate means the best. Okay. So with that, then you'll notice on yours it says DLC 2.3.1 or something .out. Just change it to match your out file. File format, 1 for the fast ASCII or 2 for fast binary. You could switch it to 2 and use the .out B, but I prefer to use the .out file. Okay, so now, hopefully now, when you run it, there shouldn't be any errors. But what do you need to run in order to see that? Well, that's a great question. If you go up to here and you do new live script, technically you could run all your commands down here and it would work, but the problem is each time you open MATLAB you would have to retype those commands. So it's just easier to do in live script. Name it, do a Control S even though it's blank, and name it something you'll remember in the source folder. It's got to be in your current working directory. So I named mine run_MLife. Okay. So now all you have to do is create a variable called settings file. Set it equal to the settings file that you created, to the name of it. Remember to use single quotes. When it's in purple, you're good. Okay, the data directory. This is what MLife uses to do all the calculations. It needs the source folder because it relies on the rainflow counting folder and the data table package folder to do all the calculations. Rainflow counting is how it does it. I suggest looking that up in case you don't know what it is. It's kind of an interesting algorithm for counting cycles. Okay, the output directory. This is where it dumps all the data. So when it writes your Excel files, it needs to go somewhere. So hence why I have a folder that I created in MLife testing called data dump. So go figure, you know. Okay, so that's where it's set to, and then here's how you call the function. So make sure capital F, capital S, do the thing. This function does the thing, and the thing is what we want because the thing gives us answers. Do not forget the semicolon. Okay, so when you hit run, you'll see all the stuff that happens here on the left-hand side. No, the right-hand side. Sorry about that. At the very end, it'll say MLife processing complete. Now, common errors are the array situation where it'll say there's only 54 indexes, so pick something between 1 and 54. The other common one is bad syntax, and it can't find the other one is it can't find the two folders, so make sure your path is set. And then the other common issue is people forget to install the statistics and machine learning. So with all of those, it should run. If not, it will have an error and it'll tell you what it is, but most likely it ran for me. It's pretty simple to get going. Okay. Alright, so now once it has run, let's go to the data dump and see what it produces. The one that I'm interested in most is this lifetime. I'm going to double click it. And it's going to open up, okay, in Excel. It's going to show that our lifetime period is this. This is 20 years. So our goal is to get our cycles to failure or time to failure to match close to this in seconds. So what do I mean by that? If we go to basic time until failure in seconds, we look at the root force x b1. Look how close that is, 6.46, 6.5. When I first ran this, I didn't I was getting interesting values like 5 years and stuff. So I was like, okay, what is going on? Why is it only 5 years? And then I realized, okay, well, what I need to do then is change my max ultimate load from what I was using and increase it until I find the right times. So what's a good starting number to start with? Well, that's an excellent question. If you go back to your force in X for blade 1, here's your max right here. That's your max load that it's experiencing at this time. So 380. So I put in 380, ran a test, and it said at 380 kilonewtons it would last almost 3 years. So I'm like, okay, that's not that good. So then, let's see. I actually might have. I actually erased the file. Okay, or did I? Let's look. Data dump. Yeah, I did. I had an Excel file that had the numbers 1, 1.25, 1.5, 1.75, 2, 2.5. I mean 2.25 and 2.5. And then I took the max loads. You know what? I'll just show you. I'll just show you what I mean. So I had 1, 1.25, 1.5, etc. all the way up to 2.5. So 380 for the force in X. So let's look at the force of Y. It's 184. Okay. And let's pretend my moment was 6,000, which I know it is. And this one is 13,680. Okay, so that's a multiplier if I multiply everything by 1. Now if I take 1.25, so it just equals A2 multiplied by 1.25, hit enter, drag and drop. I did this, okay, and then I put in all 4 of these numbers into MATLAB in my settings file right here. At least for X and Y, I started with X and Y. I kind of left the moment alone. Well, actually, no, I didn't. I used all 4 values until okay, let me re-explain that. I took these 4 numbers, put them into the settings file, then recomputed MLife, and I only paid attention to the X value until this got close to my time. Now this is 20.5 years. So at that stage I realized 806 kilonewtons is my ultimate load. That's where it fails. Like, I don't want to say fails, but that's where it hits the 20-year mark. Okay, then I increased, and then I noticed, so at 806, my Y value was not 980. So I noticed the time was really, like, it was like 1 hour for the value I had. I think it was 184 or something, and or 300, and it was like the blade would last like 1 hour. So I kept increasing that, leaving this one at 806, kept increasing this until I got close. And then I did the same thing with the moments until I landed here. So I did about 50, 60 different tests until I finally nailed it down. So now I know that with my ultimate loads of 806 kilonewtons, 980 kilonewtons, and a moment of 21,550 kilonewton meters, and so forth, that's where the blade will last 20 years. So, now the other way you could do this instead of testing like this is use ANSYS or some other FEA analysis and find out the max load that way until failure. And then once you find the max load, then you can use that numbers for your ultimate strength and then calculate and see how close you are for years and see what happens. But that should be everything for the basic MLife to run. So, okay. Alright, that's where I'm going to stop the video. So anyway, thank you for watching, and I hope it works out for you.